Alright, I think we are live. Let me double check that audio stuff is fine. Looks like it. Cool. I guess we get started. So, yeah, the plan for today is to do some flashcards and to learn jacks. It might be a bit of a shorter one because I was moving today. Audio stuff is fine. Looks like it. Okay, so define, I guess we get the KL divergence of P and Q. I'll just write this down because it's a bit difficult to say out loud. Expectation under P of IQ of X minus IP of X. Oh yeah, minus 1 times that, yeah. I'll just write this down because it's a bit difficult to say out loud. And then I'll write the in terms of just like P and X, P and Q directly, which is X minus IP of X. Oh yeah, minus 1 times that, yeah. I'll just write this down because it's a bit difficult to say out loud. And then I'll write the in terms of just like P and X, P and Q directly, which is X minus IP of X. Oh yeah, minus 1 times that, yeah. Actually, wait, no, so that should be a plus. That should be a plus. Okay, so it's expectation under P of the information from Q of X minus the information from P of X. And then you can pretty easily rewrite that in terms of like logarithms of P of X and Q of X. Actually, wait, no, so that should be a plus. That should be a plus. Okay, so it's expectation under P of the information from Q of X minus Q, and then I have a P minus Q. And then you can Q minus P for the rewrite that in information form, and yeah, P of X and Q of X. Cool. Happy with that. Define cross entropy. So expectation under P H P Q, and then is equal to the expectation under P, or minus 1 times the expectation under P of log Q. H P Q. Yeah. Is equal to the. Why does it do this sometimes? Oh wait, no, that's not the answer. So that information must be given with by minus. Oh, okay, no, this is one of the to-do ones. I should probably exclude this from like reviews or from normal reviews. Anyway, why does it do this? Oh wait, no, that's not the answer. Take the MLE intuition for KL divergence. So the value of Q. So if we consider two distributions P and Q, and we say P is our true distribution, then the value or the distribution for Q that minimizes the KL divergence is the maximum likelihood estimator. The value of Q. So if we consider two distributions P and Q, and we say P is our true distribution. Okay, suppose P is the probability distribution of which the distribution for Q that minimizes language model. What's the cross entropy of P and Q if the model is guessing words uniformly? So if we go back to the definition, it's minus 1 times the expectation under P of log Q. Okay, and if it's guessing words uniformly, then Q is just 1 over if we go vocabulary. So it's minus AP under P of log 1 mod Q. And then you take that out and rewrite this as a summation. So that's uniformly, then minus log is just 1 over vocabulary. So it's times the summation on X of PX. And that obviously sums to 1 because it's a probability distribution. Put the minus sign back inside the logarithm, and then you get log absolute value of V. And then if it can predict words with exact right frequency, then P is the same as Q, so the KL divergence is 0. And then we can apply that equation that the cross entropy equals the entropy plus the KL divergence to say that the cross entropy then has to be equal to the entropy of P. If it can predict words with exact right frequency, then P is the same as Q, so the KL divergence is 0. And then we can apply that equation cross entropy equals to entropy plus the KL divergence. Yeah, I'm gonna have to manage this because I don't want to do stuff to like show up in my normal reviews. So yeah. Yeah, I'm gonna have to. I'll just have to. I don't take this out to do stuff to show up. Okay, back to review. So when we have low arithmetic complexity, what's the relationship between Tmath and Tcoms? So low arithmetic complexity means that your communication bound. So you'd expect the communications to be much greater than the maths time. Yeah. So when we have low arithmetic complexity, what's the relationship between? Okay, so B is going to be much smaller than DNF. B is about 1024, and then DNF are typically greater than 8000. To be much greater than the maths. Right. State the suboptimal coding intuition for KL divergence. So the KL divergence of P and Q is the difference in length between the length of a message sent with the optimal code, like optimized for P. Okay, wait. So you have a true distribution P, and then there's two ways of encoding it. One is with the optimal code, assuming that the true distribution is P, and the other one is the optimal code, assuming that the true distribution is Q. And if you encode it with the so if the actual underlying data comes from P, but then you encode it with the optimal code for Q, then you're going to get a stream that is like longer by some amount of bits, and that number of bits is given by the KL divergence. If you encode it with the so if the actual underlying data comes from P, but then you encode it with the optimal code for Q, then you're going to get a so that's like for flashcard review. Yeah. Now the main thing that I wanted to do was start learning JAX, which is a library. The scaling book is pretty short. Uses JAX later on, so probably makes sense to learn it. And also like I think it's industry standard. Let's go back to the content. Is a library. The scaling book is pretty short. If I just control JAX. So yeah, they want you to know about JAX, so we'll have to learn it today. So the plan of what I want to do is like learn XOR, like just write a neural network to learn XOR, and then depending on time, maybe do MNIST. I'm not sure how you're supposed to pronounce this, but like the number recognition thing, right? I don't know how much time it will take, but yeah, if XOR comes pretty fast, then maybe I'll do MNIST, but probably not. Yeah, so I guess start with the quick start. I don't know how much time. And then I would also have to like set up the environment because I haven't actually got it installed. Maybe I'll do MNIST, but probably not. Yeah, so I guess start with the quick start. Supposedly it's similar to NumPy, and then I would also have to like set up the environment because I haven't actually got it installed. Maybe I'll do MNIST, but probably not. Yeah, so yes, so supposedly it's similar to NumPy, and then I would also have to like set up because I haven't actually got it installed. You know, I'll just install it, and then I guess we can start writing code. So yeah, actually I should probably first turn off my screen for a little bit because not sure what may come up. You know, I'll just install it, and then I should probably get a better stream setup where, you know, it's not just a black screen when I need to hide things, but yeah, actually I should probably yeah, my screen for a little bit. But that's a job for tomorrow probably. Come up. You know, I'll just install it, and then I should probably get to screen such a where you know it's not just a black screen when they need to hide things, but yeah, that's a job for tomorrow probably. Guess I'll create a new folder as well. I should probably get well, I need to start organizing my stuff. Guess I'll need you as well. But Jack's learning. Right. Well, I need to start organizing my stuff. Guess I'll need you as well. Jack's. Okay, and yeah, I'll turn up screen back on. Yeah, so there we are. Oh wait, I've got desktop audio on. That's not great, is it? We probably don't want to hear that at all. Yeah, that probably meant the first 5 minutes of the audio on this was unlistenable, but yeah, hopefully that didn't affect too much. Right. So yeah, new file, main.py. Okay, and okay, so I guess what do we want to do? So we want to make XOR. So the first things to do are like generate dataset, implement. So like I guess learn how to create a matrix. Well, matrices. Yeah, multiply them, and then also some differentiation. Sure. So data set is pretty easy because I mean there's only so many parameters, right? So I guess we can start with equals what am I doing? 0 actual 0 is 0. And then 1. Okay. So yeah, that one's pretty easy. Next one, matrices. How do we create an array? So import Jax. I don't. Is it like? Do people typically use Jax NumPy or just straight Jax? Because I don't want to learn like one of them and then it turns out everyone uses the other. I guess it's something to look up. Jax versus JNB. None of these results seem very useful. I don't know. It looks like I'll just use JMP because it seems like that's what the examples are doing. It's possible that like creating the arrays without JMP is like much more verbose. Yeah. Okay, and then yeah, at this point I will need to install stuff. Do I want to use WSL? Can I even be bothered? Not really. WB init. Probably monitor chat on my other monitor. Have they finished installing? Great. Let me see if anything's been asked in chat. No. Yeah, I guess I'll keep that up there for monitoring. So, yeah, Jack's installed. The next thing we want to do is figure out how to create an array or a matrix. So, let's see, x equals jnp dot. Oh, I really haven't used NumPy in a long time, so I guess we'll have to look this up. jnp, I think it's dot shape. Oh no, zeros like, yeah, that's it. Oh no, just zeros and then the shape. Sure. And then how big do we want it to be? I don't know, let's just say 3. Doesn't super matter for now. Okay. Actually, I should probably work out like the dimensions of the network that I want to learn. So we have 2 input parameters. Do we need a hidden layer? Yes, because it's not linear. So I guess hidden layer with like, I don't know, 2's maybe enough. I don't actually know if it's enough. But yeah, let's say that. And then the output layer just needs to be single 1 because it's like either 1 or 0 output. Actually, it's probably, no, it needs to be 2 outputs because if we want to use like cross entropy, then yeah. Yeah, and then after that, if we want, we could put another like artificial. We could put a like neuron on there to just like say if it's like 1 0, then it's 1. If it's 0 1, it's 0 or whatever. Okay. So yeah, that's what the network would look like. In terms of the like matrix multiplications we need to do, so this is, so each layer is going to be a vector of length 2. And then the weights are going to be 2 by 2 matrix. Yeah. And then we're going to need 2 weight matrices. Okay. So I guess we'll call this inputs, or Z equals I don't know. We would have to put this as the input, but like whatever. We'll call it jmp dot 0 of length 2. And then we'll have the first hidden layer be also 0s, I guess. 2. And then the output layer, or actually no, this is the, like, I forgot what they usually name it, but like, this is the, we need to also put this through a non-linearity, but Okay, I'll just call it H1. And then, yeah, the output, we'll call it X, I guess. And this is J, and we'll initialize it to zeros, and then the first weights is going to be 2 by 2. The same thing for the second weights. And then the non-linearity, so f equals, does numpy have value built in, or, I mean, it's not, yeah, I guess I'll just implement it myself. Max lambda x max of x and 0. And then we'll need the derivative at some point, right? So df equals lambda x, and then let's see, we want to return, there's going to be 0 for x less than 0 and 1 for x greater than or equal to 0, I guess. So 0, 1, indexed by x is 1. So if it's greater than 0, then true is 1. So yeah. Right. So I think that's all the stuff we need, and then now it's training and I guess inference. So we also need to define loss. So loss, and then we'll have to compare x, which is the outputs, to y, which is the class labels. Yeah. So let's see. Actually, the data set should be, because the model is not going to output 0, 1, it's going to output like GMP dot how do I just, okay, I'll just put it as a list, and then there's probably some function to turn it into Jackson NumPy array. So let's see, we'll say that the first, so it's 1, 0, because we'll say the first element means that it's 0. Same thing for here, 0, 1, and 0, 1. Right. And then we'll do cross entropy loss. So that's, can I do this from memory? I think so. So it's going to be minus, so it's already a sum, so for, I guess, I, hold on, I'll write this down, like the expression, because I have the maths expression in my head, but then I need to translate this to Python. So minus sum on I, y subscript I log x subscript I plus 1 minus y subscript I log 1 minus x subscript I. Okay. So x and y are vectors. Maybe, actually, yeah, no, it's fine to not do that so far. I guess it's probably worth asserting that the shape is the same. X dot shape, is it? NumPy shape. I think it is, but yeah, dot shape. Okay, cool. Okay, then for I in actually, you know, I'll just assume that's length 2 to make things easier for me. 2. So loss or res plus equals y I times log x I, and then minus equals, and then plus this, so 1 minus yi minus, and then this is 1 minus, okay, should probably, res equals 0, and as, okay, and then the next thing we're going to have to do is, oh yeah, so for training we want to know like the gradients with respect to like each weight, so I guess let's go and derive the like back prop. So let's see, so I guess if we start with dl by dx xi, and then xi is a function of like both of the inputs to it. So we have to sum for like the partials of the both of the like inputs to it. So it's the xi by dw, and then it will be w2 and index j. Okay, and then hold on. Oh no, it should be with respect to the activation. So H, I guess. H I guess since we only have one hidden layer, there's no point calling H1. We just call it H. Okay, and then HJ, sorry, because the jth like element of the hidden layer, and then okay, and then each of those hidden element layers depends on like both of the Z inputs, so again sum on a different variable, we'll call it K, dHJ by d zk. Okay, and then that will give us the loss with respect to each input. Hold on. No, but that's not what we want. What we want is how it changes with each weight. So dl by dx, dx by dw, I guess, dw by dh, and then dh by dw, and then the other w's. Yeah. Okay, sure. So dl dx I times sum j dxi by dwi j, or no, sorry, so it will be, hold on, so xi, yeah, I need to figure out a convention for like which element in the matrix maps to which like part of the which weight specifically, but yeah, but it'll be like with respect to, actually, so let's do that first, because otherwise then I can't really like derive what the like derivative of the loss is with respect to each weight. Oh, there should be weights too. Okay, so it's going to, the forward pass looks like forward from Z, so given some Z, we're going to do H equals W1 times Z, and then we're going to do X equals W2 times H, but then we need to pass this through the non-linearity, which will be F okay, and then are we going to do biases? Do we need biases? I don't know. We can add that later. And then F of W2 times H. Okay, and then I probably need to, yeah. And then there's other things too, like I need to put like, I think, what is it, softmax at the end, but sure, and then return X. Sure, so maybe I should return it, call the weights something different than W1 and W2, so I can, okay, I'll call this W and I'll call this one, I don't know, P, why not? Okay, so let's see. If we're doing W times, or Z, and these should be column vectors actually, right? So it should be like 2, 1. Oh, sorry, 1, 2. What am I doing? Yeah, 2 rows, 1 column, so 2, 1. Yeah, and so the element 1, 1 will be the weight that 1, 2, and then 2, 1, 2, 2, and then this top row produces the first, so like the left hand in my diagram, and then the bottom row is the right hand in the diagram. Okay. Right. So, going back to finding the derivative so let's see, probably just better to pass in a parameter, whether it's W or P, is W, and then, because yeah, those are the only two like weights that we have, and then yeah, so and then also which output. Hold on. Yeah, so we only need like which ones we want to like update, whether it's W or P. And is there like a vector calculus way of like not doing it individually for each element of W and doing it all at the same time? And do I want to ask Claude about this or like derive stuff? It's getting late, I will just ask. Oh, should do that off screen. Yeah, so the power of memory is kind of run out at this point. Okay. Yeah, okay, hold on. Apparently I need to do some things differently for this to work with Jax. So first of all, the whole point of Jax is to like not have to write the derivative function, which is good because that seemed like that was going to take me a while. So yeah, the forward pass is there, the loss is there, we defined it. Apparently I'm gonna need to like use one of their own functions for the rally instead of just defining it myself. So we'll do that. Okay, it says Jax has its own value equivalent in jax.nn. So import jax.nn, and I guess we'll have to look at the docs for that. No, not that tab. What am I doing? I literally have the docs open there. Jax 101, yes, that'll probably be good. Automatic differentiation, yes, please. Okay, so if you do one of the JMP dot something functions, then it will just, you can put grad and then it will just do it for you. Okay, so jax.nn.rally, I'm assuming it's called. Yeah, okay. Oh, what am I doing? It shouldn't be brackets because it's a function. Okay. So f equals jax dot and then dot rally df equals jax dot grad of f. Right. Okay, and then the forward pass we already defined it, and then now we need to define the backward pass. hold on, I'm just reading board output to my question. Okay, so it takes your scalar loss function and called with the same arguments, plus gives you all partial derivatives in a single reverse mode pass. Okay, so hold on, if I were to call df of what? Yeah, hold on. I probably have like not. So what other changes do I need to? Because it's talking about like computation graph, and I like vaguely remember this idea from doing PyTorch work a while ago. But from what I remember, you need to like if you want it to work, you basically have to follow like their framework pretty specifically. Like you can't just implement it all yourself. So what other things would I need to do? Oh, I should probably put this on my main screen so you can see what I'm asking. Yeah. With don't write code. Okay. Okay, so sure, apparently we don't need df anymore. The loss is there, that's just cross entry. Okay, and then use matrix multiply. I forgot about this. This is just normal multiply, and yeah, we don't use it anywhere else. Make W and P explicit arguments to the function you pass to Jack's gradient. So I guess the loss would have to therefore be a function of X and also W and P. So you know what, let me just write this. So it'll be Z, W, H, P, X, and then Y. And so I guess what we want to do is within this function, we want to call the forward pass and then compute the loss, and then Jax will compute gradients for us. I guess that's how it works. Yeah, let's find out. Okay, so call forward. And then Z. Wait, why am I defining H? Yeah, it's a hidden line, so we shouldn't need to. And similarly, X shouldn't need to be an argument of anything. Okay, so forward Z X equals. Okay. but this returns an array, right? So why is it saying that? Is it tuple? Oh wait, no, because it's an attribute. Okay. Yeah, so then I need to pass WMP here. Okay, so that's our loss. Okay, and then Jax dot. Hold on, what actually does Jax dot grad do? I'm not. So it creates a function that evaluates the gradient of this, but then with respect to what? How does this work if like we have a bunch of matrices and we want the like partials with respect to like all of the elements? I don't know. You know, I'll just write what I think seems reasonable and we'll just go for it and like debug errors. Hold on, but the things we don't want, because Z isn't, Z and Y are like not actually. Hold on. So how are we gonna do this? I guess we want to do like Z and Y, and then that will itself call loss, or WP, sorry. Okay, and then I don't know. We'll just have to figure out a way to inject Z and Y in there somehow. This feels kind of like I'm doing stuff wrong. I'm not really sure how you're meant to use this. Because we don't care about the. I guess we can just throw away the gradients with respect to Z and Y because it shouldn't. We definitely don't care about them, but yeah. Okay, so if I just, I guess, run this and see what happens. Like, probably get an error somewhere, but then. Oh yeah, and then we need to do softmax on X. Sorry, X. Jax must have one of these, and I think we probably need to use it. Jax softmax. Okay. X. Okay. Let's see. UV run. There's no way this works. Oh yeah. Why is this taking so long? Okay, well, it's done something. How am I supposed to get, like, useful numbers out of this? Well, it didn't crash, I guess. But then, hold on. Yeah, this, okay, it says not to use zeros, so what is the syntax to do? NumPy random array. This is probably not very enjoyable to watch because it's just me looking up blocks, but like hopefully within a couple of days I'll be at a reasonable level of like understanding to the point where I'm not having to look everything up and be confused all the time. Okay, random.rand. Wait. Or does Jack's NumPy even have random? Hold on. Okay, it's Jack's.random. And then, yeah, 2, 1. What's going on? Oh, no, so we need to initialize it with zeros and then, okay. I'll just look at the docs. Jack's random module does not have any, great. None. Okay, so it returns a thing with a shape of, hold on. Okay, and then it'll be Jack's dot, okay, jnp dot zeros to, and then there's surely got to be a better way to do this. Oh wait, okay, apparently I need to seed this first too. Key dot jack, sorry, key. Okay. And then it's key and then shape equals. Okay. Okay. Right. And then, okay, going back to trying to find the actual. Okay, and then, so this is a gradient of the loss. And then we'll call it onto value. So let's say Z is our input, and let's say we want to calculate the XOR of like, I don't know, 1 and 0, which should be 1. The weights are W and P, and then the output that we get should be from the data set, and then it's the tuple version of like, yeah. Yeah. So if we print that, what do we get? And actually, we should probably. They said what it was like the Jack's value in grad or something like this. Okay. So that we can see the loss in the. Please work. Why does it take so long? Okay, cool. Errors. So is this something that would why would we not want to use? Okay, I'll just put 1.0 and 0.0 and call it a day. Oh, okay, and then I need to J and P dot what was it, array. And then this should also be JMP dot arrays. Okay. Okay, yeah, neither of the shapes are going to be 2. I'll just remove the assertion and hope it doesn't, like... Okay. It seems like it's done something. I guess the first thing to do is like, can we just like figure out what the weights should be? Or actually, can I be bothered to go through and derive this? Yeah, I'll just ask Claude, like, what are the weights that you would expect for a model of this size that's doing XOR, and it's probably like something that you can determine, I think. So yeah, I'll give it my forward pass and my loss function, and the like initialization, and I'll say, what are the like weights that you would expect to do the thing? And then we'll see if those weights like give you 0 loss. yeah, hopefully this is um okay. Apparently I've made some more mistakes that I need to fix. So apparently value and grad only differentiates with respect to the first argument. Why? I don't know, but is that indeed the case? Okay, so argnums is that's the parameter that we want. JMP array this. And then it's arguments. Is this 0 indexed or? Yeah, 0 indexed. So it's 1 and 2 that we want. You know, I will like we'll call this something else. Value. Okay. So that's one thing. Apparently my loss is also wrong. Okay. Oh, okay, yes, but this isn't necessary because this is just classification. And yeah, I guess I don't need to do the for loop. Okay. So, yeah. Now, this should be able to learn Excel, but obviously we need to write code to train it. But let's see what the loss is. Wait, what am I even looking at here? So the loss is this, I'm guessing, and then the gradient. So this, okay, so this is the first thing, and this is the second one. Okay, and it's saying like we should update this based on this. Okay, that I guess makes sense. And then so to train it, what we would print that, but then for equals this is actually rather simple now that I think about it. I think I was overcomplicating it because I was going into this expecting like I'd have to write literally everything from scratch, but it does differentiation for you, which is quite nice. Yeah. I'm probably not going to do minutes today, but I feel like I've learned something so far, and I should be able to finish this today. Okay. So what was the expression again for the weight? So the new weights equals W plus eta times the gradient. Oh wait, hold on. No, we want to minimize it, so we should subtract some amount of the gradient. Minus eta times and then hold on, let me print the gradient to see. But I think it should just be grad applied to thing. Or actually, you know what, I should write a proper loop for this. Okay, so for wait, am I able to index this dictionary by numpy array? That would make things a lot easier. Yeah, I don't think I can. It's not hashable, right? Yeah. So what can I do about this? I can make dataset a function. Yes, I think that's probably the easiest thing since it's actually a function. x0, what's x? Well, I think it's caret in Python. x4, x1. Oh, that's not big, always x4. Hold on. So Python. I mean, it shouldn't matter anyway because, yeah, I guess just to, I'll end them and then float them at the end. And yeah, we'll only do it on zeros and ones, so it should be fine. So for so actually you shouldn't use x for I. Okay, so that's one epoch, and then we want to do multiple epochs, so for I don't know, let's do 10 or something. So, and then we want the binary representation of this, so this will be, let's see, this will be float I mod 2 float I is greater greater than or equal to 2. Yeah, or I guess greater than 1. Wait, hold on, if I do float, you know, I'll just do float I divided by 2, and yeah, that should be fine. And then data set of, and you know, I'll put this as like is and then eta, I don't even know what it should be. I guess 0.1 we'll call it. Okay, and then we need to do the same for p. And also we should index this because it's like, this will be the 0th one. And then the first one will be p. Okay, and then I guess we can just print the value and gradient for this, and hopefully it goes down. Or actually, not even value and gradient, because we only want the value, so we'll just call loss. Loss. After every bug, print the loss on like, or I don't care about the loss on each individual one as long as it's getting better in total, so just the sum of losses. Plus equals okay, and then hopefully this like goes down. We'll see. Oh, my face has been off screen for like a few minutes. Okay, well, the loss seemed to go down a little bit. Maybe not as fast as we wanted. Let's see if I put 1,000 epochs. Will it get better? Oh, sorry, 100. I mean, the loss is going down. This is good. It's not seeming to learn it very fast. Maybe my learning rate is too slow. I have no idea what it's supposed to be. Yeah, I'll set my learning rate a bit higher. This is cool though. It looks like we've correctly written this. This is not great. It seems to have converged to some loss that is like not 0. And it should definitely be able to learn this. So let's see what's going on. I guess after this we want to print W, print P. And then yeah, print like value and gradient for every possible, well, not the value of the loss, we want to do the forward pass and see what it does. So forward on this, and wait, what arguments does it take in? It takes W and P as well, right? Yeah. Okay. Okay, this is not good. It seems to have, like, learned something that doesn't quite look like, what we want to do, which is, like, it just learns to minimize the loss by, like, setting all of them to 0.5. Why? Huh. How do I get it to, like, not do that? Maybe the initialization is, like, bad? I don't think so. Because the thing is, it can definitely learn better than this, right? The problem is it gets stuck in, like, apparently a local minimum. And, okay, I'll just choose some, like, different initial values and see what that does. So it should be able to get to 0 loss for this. Or, like, very near 0. What are the other random distributions that we can give it? Like, okay, uniform, I guess. We'll try that. Seems to be getting stuck in the same minimum. Yeah, that's not great. Yep, just doing the same thing. The thing is, if I set them all as zeros, I think that also is not great. Let me print out W and P initially to see what... Because the problem might be that they're all, like, quite close to 0. Okay, so this is W and this is P. So that... Oh, we need to change the... So W and P both start out the same, which is probably not good. So yeah, I'll just... Why is it that if you call it again, like... Huh? Because I'd anyway. No point trying to, like... I'll just... But why am I saying Z to be anything at all? This is, like, completely pointless. That doesn't do anything right. Yeah. Okay, so then I'll need to set a different key for... Because, yeah, I hope that it's not just that P being equal to W causes it to be weird. No, it still seems to be doing the same thing. Right. Well, it's perfectly learned to output 0.5. That's great. So how do I get it to like not do that? Let's check chat. It's been a while. Okay, it doesn't look like anything new. Oh, okay, wait, I need to bias it. That's the other thing. And then... Okay, so Claude says the issues are I need to add biases. I need to do not add a value in the like last layer, so this should just be P times H. And then I guess jackstone and then that's softmax. Okay. And then I need to learn biases as well. And then, so this means I need to change some of the stuff a bit, like, okay, so I need to initialize B1 and B2. And I guess while I'm at it, I'll rename this to W1 and W2 because the reasons that caused me to like, where's the FN key on this keyboard? I guess F2 just always does F2, yeah. Okay, and then B1 and B2. Okay, and then I need to pass in B1 and B2 as well. Okay, and then for the loss, now it's 1, 2, 3, and 4. Oh, okay, because B1 and B2 are not defined. Yes. And then what's the shape of B1 going to be? So W1 times Z is a column vector to 1, so B should also be a column. Print these separately. Okay, and I need to learn B as well. So oh. Right, hopefully this just works. Okay, it never just works first time. Print value and grad. This should also be 3 and 4, I guess. Although I don't really need that print anymore. Whatever. Right, what? This is like worse now, and it doesn't seem to be improving either. That's not good. Okay, let's see what the outputs look like. It's just doing the same thing as before, basically. Why is this? Because we have the biases now. So it looks like okay, what could be going wrong here? So the problem before was we were basically softmaxing 0, 0 because the bias wasn't there. But then why is it doing the same thing here? Oops. Okay, so it seems like in the loss that Claude has written, it adds some small constant to the logarithm. I don't know what the basis for doing that is. I guess I'll ask.
Oh. Okay. Seems like I'm making a few mistakes. So first of all, call this once. Okay, right, and then, oh yeah, that's silly me. Then what else do I need to do? So scalar label makes loss 0 for half your data. So what's data? Oh, okay, yeah, dataset needs to return. Yeah, okay, I'll just write this properly. Let me not try and cough it. Okay. X. Okay. So int XOR int x1. Okay, and then if it's 0, we want to return 1 0, and then if it's 1, then 0 1. Okay. Okay, and then apparently something is wrong in the forward pass. So what's going on? So W1 times Z plus B1 produces shape 2 2 instead of 2. What? Huh? Okay, so Z should be shape 2 1. Okay. instead of 2, so this should be just copy this. What? Where is this? Line 44, data set A. Oh, okay. So what? Huh. I think also we should, yeah, fix this. In fact, I'll just get rid of this because I don't need it for anything. Okay. That cannot be right. First of all, why is it returning 1 for both of them? Because surely softmax means that it can't do this. Yeah, that's suspect. And then why is the loss 0 immediately? Is it? Should this be a multiply? Yes, because we want to do element wise. But then, okay. So for the thing is, if it predicts 1 1, right? Then, so if the label is 0 1, but it predicts 1 1, what happens? So for the then we get 1. That's the result because 1 times 1 is 1. If the output is 1 1 and the label is 1 0, then it also gets. So I feel like my loss is wrong, but then. How would. How do we penalize it for doing that? Why can it even return 1 1? That shouldn't be possible, right? What? So hold on, let me just print out this every time the forward pass happens. Okay, you know what, maybe I should just stop this. And then if we softmax that, why is that not just like 0.5, 0.5, and why is it 1, 1? Why, what? And then, you know, I'll just call x. What am I? I've got to be missing something here, right? This doesn't. Oh, I think it might be doing it on the wrong axis. So axis equals. I can never work out how the axes work. I'm gonna just say it's 1, and then we'll see. Maybe 0. I can never, yeah. Yeah, that looks like what we would expect. So axis 0 is the 1, I guess. So yeah, with that hopefully fixed, let's see what's going on. No, but now it seems to be learning 0.5, 0.5. Yeah, it's doing that. So, I mean, at least it's doing something now, but then why? So first of all, did I fix all the issues from before? So, the shapes are correct now. The loss is also not a scalar. Because yeah, that. The thing is, I don't know. I mean, I can not tell whether it's like I need to change some of the learning parameters or if there's a bug in my code. I would assume it's the second one, but like, oh, okay. Apparently the initialization needs to be not just positive. Yeah, that makes sense because then you're stuck in the linear part. Please, please, please. No. Still just stuck there.
let's look at the initial weights, but it's definitely got some negative weights now, right? Like, I think this was the old one. Yeah, this one definitely has some negative weights. It starts out with, but I don't know what. Yeah, I think it would have been a bit ambitious to do Eminist today. It's also getting like late enough that I can feel myself getting tired now. Okay, also apparently maybe my learning rate is like too high. I'll try it with a lower learning rate. I don't even know what like is considered big or small. Okay, I mean this is definitely. Okay, it may well have just been that my learning rate was too big. I'll do like more epochs. Why is it so slow as well? Yeah, okay, it was literally just learning rate too big. And also the problem with like them being positive. This is good though, number going down. Hopefully it reaches 0 within 1,000. Yeah, okay, I guess I'll just have to like binary search for a good value of the learning rate. This is really, really slow though. Why is it like, I feel like I should not be able to watch each individual like pass going, because it's not doing that many matrix multiplications, right? Oh, okay, probably the printing is what takes the longest time. This is weird. It seems to have learned this and learned this, but not learned this or this. Why? that seems much more like a bug than it just being a learning problem. Because this is what? That's 0, 0. And this is 1, 0. So the problem is maybe 0. And that doesn't make sense though, does it? You know, let me just try with a bigger learning rate first and then see if it gets stuck the same place. Okay, so it seems to get stuck in the same place. Oh, it's even getting worse now. That's not great. Okay, so that does seem like a code problem. Okay. It's saying that maybe I should add more, like, neurons to the hidden layer. I guess. Let's see. So that means I need to change the shape of W1 and W2. So, let's see. So I guess we can change this to like 2, 4, and then change W to 4, 2. I guess it would be. Yeah, and then the biases. You're going to add. So this is going to 4, 1. And it's going to be 2, 1. Okay. I hope I did the shape maths correctly. I mean, we'll find out very quickly if I didn't. Yes. Okay, so what's going on here? W1 times Z. So that needs to be 4, 2, I guess. 4 is the number of rows, and then 2 is the number of columns, so yeah. Okay, and then this would be 2, 4. No, it's stuck in the same place. Why? Maybe loading rate too big. I don't think it is, but I'll try it with a small loading rate. Why does smaller learning rate just... Well, okay, I guess it's just doing the thing of like it keeps oscillating around the local minimum, but like not actually getting towards it. But it's kind of annoying me that like you just make a small change and it just gets. Anyway, this is cool. Lost pretty much at 0. I'll just let it write out the full 1000 and then we see. But I mean, presumably all it's going to do is just push the weights as close as possible to like infinity. But I mean, that's kind of what we want. So that's weird, because it should be able to learn with just 2, 2, 2, right? So I don't know. But anyway, does this make sense? Yep. Okay, so we successfully learned XOR. And that only took like what, 2 hours? Yeah. A lot of work for what could be 1 line of code, but yeah. Okay, I think I'm happy with this. Should I go through and comment it? I suppose it would be good for my own learning, but like, I don't know, I also don't expect to come back to this. This I'll be able to figure out what it's doing. This is also fine. The thing is, I think that I didn't, like, when I was coming into this, I didn't really understand what the point of Jack was. I thought it was literally just a numpy replacement. So yeah. I mean, it's not. It doesn't actually seem to be doing that much more than NumPy, with the exception of automatic differentiation stuff, which is nice. It feels like not too much of a, how do I put this? Like, the level of abstraction is like not too high, but it's also not low enough that I have to like sit down and like actually compute derivatives by hand. Yeah, I think I'll leave it uncommented. Future me can like decode this, hopefully. And then stuff to flashcards. I don't know. I guess stuff around the initialization is probably what I should have known, and then also like learning rate stuff. I don't know. I'll probably just like get good intuition for that. But yeah, I think it's important to know that if we're going to use rally, then some of the weights definitely have to be negative when we're starting off. Yeah, so I'll put that in flashcard somewhere. I'll just have to make a miscellaneous stack. Wait, how do I phrase this? Like, what do we need to know about the initialization of weights in a ReLU network? Or, okay, so what? For a Okay. So yeah, I guess that's it for today. Well, the things, I started the stream on Saturday and now it's Sunday. But I will stream again today, but that will be day 4. So yeah, I'm gonna end stream. I'll check chat once more, but I don't think anyone's said anything. Yeah, no. Alright, goodbye. Yeah, that's it for today.